as well as access to the virtual labs that you will be able to access after this session and continue using it in your own time as well. So the slides will be made available going up onto Sketch. If you don't see it on the schedule site, you can reach out to me directly and I can share it as well. So the first thing is if you're going to be following along, there will be some hands-on work. You will need an account on the APNIC Academy. So the blue link there, academy.apnic.net. You can access that website. You can't do it from a mobile phone. It will have to be from a desktop because it's going to be a virtual machine. So you need a full-size screen to look at it. The accounts for the APNIC Academy are free. They are not just free for you in this room, people that are watching online on Zoom. These are free for everybody worldwide. The APNIC Academy has a lot of different recordings and courses and training. Some of it on security, a lot of it on networking technology, IPv4, IPv6, routing protocols, BGP, OSPF, DNS security. So a whole range of different topics that you can go through and learn on there. We're going to be making use of a virtual lab. It's called the Vulnerability Scanning and Penetration Testing Lab. So when you log into the APNIC Academy, you just create a free account with your name and email address and a password. You then access virtual labs and go to the Vulnerability Scanning Virtual Lab. From there, you can launch the lab. It's a full virtual machine. It's basically running VMware on the back end of things. It will take 1 to 2 minutes to launch the virtual lab, so you can get that started up early. The instructions and resources, you'll see the information like this here. You'll see up in the top right-hand corner of the screen, instructions guides you through the step-by-step and the text to follow through. The resources gives you the username and password to log into the different virtual machines. We won't be changing virtual machines for this lab, but other labs that you may access, you may need to change to different virtual machines. When you're going through the instructions, you may see instructions that look like this. The green text with the little green T in a square before it, that signifies text that if you click on it, it will automatically type it into the virtual machine. So we're not testing your skills of reading off a slide and typing things in. If you wish to type the command by hand, you're more than welcome to. But if you want to save all of the manual typing, you can just click on the T and it will input that text wherever your prompt is, wherever the cursor is. So you have to make sure if you want it in a web browser in the virtual machine, you have to click on the address bar. If you want it in a terminal window for the Linux terminal, you have to click into the Linux terminal. And once your cursor is flashing in the terminal, you can click on the green text and it will put it in. The other thing, the lab environment is set for 3 hours of time. This can be extended when you reach to the end. It'll give you the prompt saying that you can extend it a little bit. After the session expires, your lab will be saved in its final state. The labs can be saved for 7 days. After that, they will be exited automatically. Similarly, if you go into the 3 lines in the top right, you can choose to save or end. If you end, everything is cleared off, but you can start it up again. It just means it will be starting from a fresh state. And I'm not sure why my text cleared off, but that's fine. I explained what's hiding underneath there. Okay, so that's the virtual lab. So just for anybody who is coming in a bit late, academy.apnic.net, create a free account on there, and you can go into the virtual machines. Okay, so on to the main topic, because there's theory before any of the hands-on here. So this is looking at vulnerability assessment and penetration testing, and it's looking at the differences between them and the similarities as well. So first off, looking at what is a vulnerability assessment. So a vulnerability assessment is a methodical view of all vulnerabilities within a scoped network or system. So methodical review, we're looking for all the vulnerabilities that can be detected at that point in time.
And when it talks about a scoped system, it basically is that you have to define what are you scanning? What are you looking for? You may want to look at a specific network or a specific group of servers or workstations or networking equipment, but it usually is not the entire network. You usually would be segmenting it into different scannings for different purposes at different times. The goal of a vulnerability assessment at the output is to have a prioritized list of vulnerabilities that will then guide you in what are you supposed to be remediating first, which are the most important ones, and providing that information to the people that manage the different systems. You may have different people managing the network equipment that you have to managing regular servers, and maybe different people managing database servers as well. Vulnerability assessments are usually performed when you know you have some problems on your network, but you don't know exactly where they are or which ones are the worst ones that need to be modified and rectified first. Vulnerability assessments are typically broken down into two categories of types of scanning: credential or host-based scanning, or uncredentialed network-based scanning. When scanning for vulnerabilities over the network, that can be performed with no special access other than having an IP address on the network and being able to communicate with the machines. Credentialed scanning is usually host-based. This is done by sometimes installing an agent software on the machine, and the agent has permissions on the local machine to interrogate locally installed software, configuration errors that might be on the local operating system or software. But you can also do credential-based scans over the network. If you take a Linux machine, for example, if you have the username and password to SSH into that Linux machine, then a vulnerability scanning software can log into a Linux server, and then once logged in, look internally for configuration errors, maybe file permissions that are a little bit too excessive, or pieces of installed packages and software that is not allowed. So a vulnerability assessment is usually seen as part of an audit. This is usually something that is required if you have any compliance requirements, if you're following ISO 27001, if you're following any of the NIST frameworks, or if you're dealing with credit cards, you may have to manage PCI DSS certification. But these vulnerability assessments are usually part of some sort of an audit process as well. Comparing and contrasting this against penetration testing or pen testing. Pen testing are simulated attacks to compromise a system, again within a scoping of the network. So usually when someone's performing a penetration test, they're given a scope of which IP addresses they are allowed to attack and how they're allowed to go in and perform their scanning. The goal for a penetration test is not to find every single vulnerability. The goal is to actually break in and gain access to sensitive information as defined by the owner of that network. This is sometimes called the crown jewels. This is the most valuable part, or seen as the most valuable part to the organization. So for some companies, this might be a customer database. This might be a finance system or database that they may have access to as well, or just purely gaining access to the authentication system. When people are learning to do penetration testing, they usually do competitions called Capture the Flag, or some online games called Capture the Flag. Capture the Flag is all about the flag. So in CTF competitions, instead of going after the crown jewels, you're going after these flags that are worth points. Now, penetration tests are usually done to test and assess the level of security for mature systems. If you know you have a lot of vulnerabilities, a penetration test is just going to find the vulnerabilities you know, exploit them, and finish the test through the very large holes that you have on the system. So generally, what you're going to be doing is running those vulnerability assessments first, finding the vulnerabilities, fixing the vulnerabilities, retesting those vulnerabilities to make sure that they are resolved. And then once you know that you're in a good security state, You then get somebody come in doing a penetration test where they're looking for things that the vulnerability scanners didn't find, or they're looking for new vulnerabilities that may not have existed before. Now, I talked about scoping for both of these types of activities. The scoping is covering things like what domain names are involved, what IP addresses, maybe only certain networks or servers or devices, and you may specifically exclude certain systems from the scoping as well. Now, this is an important part, whether you're doing these tests internally or if you're hiring an external company to perform these tests for you. If you have some very fragile systems, you may want to exclude them. If you know that a system will reboot if it's scanned, you may be working on getting it replaced, but it's not able to be doing it until next month. You don't want the scanning to go in and compromise that system. You also may want to look at the depth of the assessment. Some of these scans can take more time and be a lot more intrusive onto the systems. Additionally, you may want to test if a system is vulnerable to a denial of service attack. Not so much a distributed denial of service attack, but just a regular denial of service. Now, if you have critical systems in production, you may not want them being tested for denial of service because it may actually crash your production machine. And if you're uncertain, you may exclude that from scope or say, no, we're not going to do denial of service attacks against this one machine. You also want to look at what is the goal or the objective. When we're talking about vulnerability assessments, the goal is straightforward: find all vulnerabilities. But for penetration testing, that's where you need to find what is that crown jewels. What is some valuable part of your network or your systems that would be critical if an outside attacker or criminal were to break in and gain access to that part? And then you can break down that testing further into black box testing and white box testing. Black box testing is where the penetration testers are given no advanced notification or no advanced knowledge of the systems. So you might tell them your IP addresses and domain names, and that's it. You don't give them a network map. You don't tell them where the web servers are. You don't tell them what applications are running or anything like that. You just give them IPs and domains, and that's it. And that's compared against white box testing. White box testing is where you do give more information to the penetration testers on the assumption that any external attacker, if they spend enough time, they will collect all this information already. Now, remember, if you're hiring an external penetration tester, you're paying them based on their time. The time to do the scoping, the time to do the technical assessment, and the time to write up reports after the fact. Because you're paying for their time, you may want to tell them things up front that they can figure out with enough time. So not just telling them IP addresses, maybe giving them a list of all the DNS names that you have for different systems and pointing out where the different systems are. You're not giving them any special access, but you're speeding up the process before they actually do the penetration testing itself. Now, of course, we're basically doing simulated or, realistic, hacking and computer compromises here. So we have to make sure that we understand the legal issues. This is legal issues if you were going to do any of this type of scanning or penetration testing, but is also if you're hiring an external organization, if they don't follow certain things, you need to understand what needs to be agreed upon here. So at the very beginning here, when you're performing actions that look like an attacker, that look like a criminal, you need to make sure that you're staying on the right side of the law. It's okay for you to test the security of your own home. It's not okay to go up to your neighbor's home and start testing the security of their doors and their windows, especially without their permission. And this is the same thing. The same thing that are laws that you have in the more physical world are also applying on the internet as well. If you were to go through and do any of the certifications and training courses, the big, CEH or Pentest Plus or OSCP, they all have entire sections that talk about the ethics and a code of ethics around penetration testing. It's not just as simple as only test your own things or only test with permission. But what if you find a critical vulnerability? What if you're testing someone else's network and you discover evidence that a criminal is already inside their network? What do you do at that point in time? Who do you contact? What evidence do you need to collect? Do you continue? Do you stop? There's a lot of things around that here. And a lot of that is not just a code of ethics, but also an agreement with the person that is contracting services. From the simple perspective, stay legal, always have permission for whatever you're doing, not just permission for the destination, but whatever local network you're starting from. Some networks do not want any malicious activity leaving their networks at all. So they may actually see the traffic that you are using that is leaving your network and say, hang on, it looks like you have a criminal on your network. So it's not always the legal side of who you're assessing, but where you're coming from as well. Now, we also not just have the black box testing and white box testing, but we also have different groupings of hackers here. The black hat and the white hat. This, of course, is going back to American Westerns and Western TV shows and movies from many years ago. These TV shows and movies were all shot in black and white on camera. Now, colors don't come through very well in black and white. Additionally, for the audience, they needed to know who's the bad guy and who's the white guy or who's the good guy. And what they did is the bad guy, the bad cowboy, would be wearing a black hat. And the sheriff or the good guy would always be wearing a white hat so that the audience could easily see who's the good guy, who's the bad guy. That's carried forward into this malicious activity side of things as well. Black hats, very simply, these are the criminals. These are the ones that do illegal activity without permission. The white hats are the security professionals. They're staying on the right side of the law. They're usually the ones being paid to do either defensive security or offensive security, and they do it legally with permission. Now, gray hat is where things get really interesting. There's no one strict definition on what a gray hat hacker is. Obviously, it's somewhere between black and white, but it can be in that middle for a lot of different reasons. For example, you can have somebody that used to be a black hat, used to do a lot of illegal activity, and then has decided to move over to the white side, has decided that they want a stable job, so they apply as a security professional, but they obviously have a lot of illegal background behind them. So that's that gray hat of the black moving towards the white. Another definition for gray is you can actually have a white hat hacker who is a professional in their day job, they're learning security, they're doing vulnerability research, and then at nighttime when they go home, they perform illegal activities. So they're using their professional knowledge to then perform illegal activities separate to their job. Yet another definition of gray hat hacker is where you have somebody that is performing illegal actions, but after the illegal action, they are actually implementing security and protections on the servers. So they may break into a server purely for the benefit of changing the configuration so that other attackers and criminals can't break in. So they're performing illegal actions, but their motivation is good. All of these are different definitions of gray hat hacking. So if anybody ever says they are a gray hat hacker, you say, well, what do you mean by that? Now, there's also websites that will then break down not just black, white, and gray, but they'll give you blue hats and green hats and yellow hats and purple hats. If you look for those on several websites, they will all be different definitions. So going beyond black and white, anything else is, excuse the pun, but a gray area. So any other white or any other definitions of colored hats, there's no strict definition for what they are. So if you ever see someone saying that they are a green hat hacker, you need to ask them, what do you mean by green hat hacker? Because there's no strict definition for what it is. Now, penetration test reports, this is the end side of penetration testing. The report is the actual important part. The report is actually where they are giving proof that they were able to break into a network and where the vulnerabilities are and what allowed them to get through. So it's dramatic proof that you have vulnerabilities. A vulnerability assessment will list out vulnerabilities, but it won't actually test the vulnerabilities. It may say your mail server, your, on-prem Microsoft Exchange mail server has this vulnerability, which could be exploited to do remote code execution. That's what you get from a vulnerability scan. A penetration test will find the vulnerability and exploit it and break into your mail server and give you the proof that if I, the penetration tester, can break in, then other people, criminals, can also break in using the exact same methods and techniques. So these pen test reports are absolutely critical, and this is where we have good penetration test reports, and sometimes we have not so good penetration test reports. A good report will document all the actions that were taken in a way that can be reproduced. A penetration tester is not holding on to secret knowledge. They're just following procedures and using skills to go through and exploit a vulnerability. If they can document that, then you, as the defending side of things on the security for your networks and systems, you can make the fixes, upgrade the software, change configurations, and then follow the same procedure to make sure that what you did would stop it. So a good report will include actions in a reproducible form. A good report will detail the amount of effort it took to break into different systems. Sometimes you just find a script on GitHub and you run it, and boom, you've got access to a machine. Sometimes you get Metasploit, you execute a script on Metasploit, boom, you're inside a machine. That's very low effort. Knowing that is important from you as a defender side of things. If any random 12-year-old can download a piece of code off of GitHub and break into your network, you probably want to be fixing that earlier than the thing that took, hours of coding and finding a new vulnerability to break into a machine. So the lower the amount of effort required, the larger the vulnerability is going to be. Another thing that you have here, so another good report will have actionable intelligence. So not just telling you what you need to do or what was wrong on your systems, but telling you what to do to fix your systems. So it might tell you that you have a certain cryptography weakness on your Wi-Fi network, and you might go, well, that's great, but I'm just using the default settings. What do I need to do? A good penetration test report will tell you, you have this problem on your network, you should change this setting, and that will then get rid of the vulnerability. There's also a large collection of penetration test reports. I don't know if this one's still being updated. I've got a few other links that I was just seeing on some discussion boards last night. So if I do find some updated links, I'll put them in there before I share these slides out to everyone. Yeah. But the benefit of these is not the currency of them, but how they're laid out and what types of information. These reports won't help your network, but if you're ever going to be learning penetration testing, you need to know how to write a report. And that's where these reports come in. So even if these are a little bit old, they're still valuable information. But these are not useful for defending your network. These are useful for you in writing a good report. Now, any of these sorts of scanning, whether it be vulnerability assessments or penetration testing, there will be benefit of doing these on a regular basis. Now, I mentioned that some vulnerability assessments are done as part of an audit, and these audits are usually done for compliance, like ISO 27001 or PCI DSS. Some of these will say you only need to do a vulnerability scan once a year, or maybe twice a year. Twice a year gives you a 6-month window where a lot of things can change on your network. The more regular, the more frequent you're scanning, you're testing, and doing your assessments, the faster you're going to find vulnerabilities and allowing you to then remediate them and fix them so that criminals aren't exploiting them. Also, as a minor note, any of these compliance like ISO, NIST, security frameworks, PCI DSS, any of those compliance is a very low bar. You know, it's like building a fence this high. Sure, it's going to keep some animals out, but anyone who really wants to can just sort of step over that fence and come in. So just because they say the fence must be at least this high, you can build your fences higher. You can build your defenses stronger than what the minimum is for compliance. Now, some of the vulnerability tools, the professional vulnerability tools that you may have can actually do continuous scanning. So it starts on one end of your network and it scans through for vulnerabilities, and then it just comes back around again and it looks again and again, and it's continuously looking for these vulnerabilities. These are very common when you have agent-based software on the endpoints, where not only is it, you know, agent-based for antivirus scanning and malware scanning, but it's looking for what software is installed, what versions are installed, and what vulnerabilities may exist. So those, you know, this continuous scanning will obviously catch the vulnerabilities a lot faster. Penetration testing, penetration test, a repeated penetration test is best done after you actually do remediation work. If you contract a penetration testing company to come in on the first of every month and do a penetration test on your network, if they come in and they do it, but then you don't do anything with the information that you get from them, the next penetration test will just find the same vulnerabilities. There's no improvement. So when you're doing a penetration test, you pay for the penetration test, you get them to do the work, you get the results, you actually need to remediate, you need to mitigate and fix the vulnerabilities that were detected before you bring them back in. Otherwise, they're just going to find the same thing. Similarly, by nature, a single penetration test may not find all the vulnerabilities. So by bringing in another penetration testing company, they may be looking at things from a different angle. There's no set concrete level of skills and experience to be a penetration tester. You may get a junior person. You may get a senior person that only understands network vulnerabilities. You might find another senior penetration tester that understands web application security better. So you need to look at what is the penetration test focusing on and maybe rotating that around throughout the year. Okay, so penetration testing is basically acting like a criminal. You know, it's that simulated attacking. So to understand penetration testing, we need to understand actual attack life cycles as well. So this is the exact same thing that a penetration tester would follow, that also a criminal would follow through as well. At the beginning, we have reconnaissance. This is the collecting of information. At this point, they're not actually compromising or breaking into any of your systems or networks. They're just collecting details. They might be finding exposed password lists. They might be scanning for your ports, figuring out what IP addresses, what domain names, what versions of software you have installed. All this reconnaissance is building up information to allow them to execute the next step. The next step being initial compromise. This is where they use that information gathered in reconnaissance and they break into the first machine. This might be breaking into a web server that is publicly exposed and has a vulnerability. This may be sending a phishing email to one of your users, getting them to click a link, download some software. This could be social engineering, this could be network-based, this could be web application-based. Whatever it is, it's the first break into your network. From that first break, they're going to be establishing a foothold. At this point, whatever the first way that they got in might not be reliable. For example, phishing. You may get one person to fall for a phishing email, but getting them to fall for it again or a different person may be difficult, especially if there's phishing, you know, detection software out there as well. So after they get into that first point in your network, they're establishing a foothold that they can come back to the network easily. This might be opening up a reverse SSH tunnel. This might be changing a username and password or creating a new user account that they can log in, or maybe changing firewall rules. This is whatever they can do with the permissions they have already. Now that's limited, which is why the next step is once they have that foothold, they can come back into the network, they look to escalate their privileges. Usually if you're coming in and you've got access as a user on a network, that will only get you so far. If you can escalate to root level privileges or administrator level privileges, that's going to let you do a lot more on those systems. After escalation, you then use that computer to do internal reconnaissance. So if we imagine that I'm on the outside of the network and I'm breaking into a web server that's in a DMZ network sort of thing, from the web server, if I can install software, the web server can scan the database server that's next to it. Or if I've broken into one workstation on your client network, I can then use that workstation to scan other workstations that are not publicly accessible to the internet. So this internal reconnaissance is using your foothold in the network to then do scanning. From there, once they find weaknesses internally, they're going to move laterally. They're going to move from system to system in your network, looking for systems that give them more access, to give them more permissions. If they can move around and get access to a backup server or an authentication server like Active Directory, that's going to be amazing. Then they maintain presence on that new system they've gained access to, escalate privileges if needed, and then use that new system to scan around and move again. And this can loop around again and again and again. You can actually get to the point where if this is a determined criminal, they can spend weeks or months on your network, mapping it out, and sometimes actually mapping your network and knowing your network better than your own network engineers. Because they have motivation, right? They're after that big payout, whatever it is. Whereas your network engineers might go, oh, we did a network map and I'm too busy to go back and update it. So your criminals can actually have a better view of your network than you do. And at some point, that loop is going to exit out and they're going to complete whatever their mission is, whatever their goal or objective is. Usually that's going to be financial. Some way they're going to try and make money out of their criminal activity. But let's say that this is a state-based actor. Let's say that there is another country out there that can get a competitive advantage by stealing intellectual property. That's going to be what their mission is right there. Say they have exfiltrated information and they want to cause you a lot of pain and damage and maybe charge you a ransom. The mission might be data exfiltration and then ransomware install all your computers and shut them all down. So that mission, whatever it is exiting out of that loop. So that is the attack lifecycle in a short nutshell. Now, just to reiterate some legal issues when we do some hands-on exercises, the virtual machines that you can use on the APNIC Academy, specifically, we have ones for doing vulnerability assessment and penetration testing. So you only have permission to do the penetration testing on the penetration testing vulnerable machines. Okay, so the other virtual machines that are available for doing other types of learning exercises, you can't use those for penetration testing. Additionally, the virtual machines for penetration testing are closed off to the internet. There are 3 virtual machines. They can talk to each other, and that is it. There is no public internet access in or out, and you only have permission to do the penetration testing on that network in the IP address range there. Additionally, just because I'm teaching you some penetration testing knowledge and exercises and experience for testing within your known network, I am not giving you permission to go back and execute these testings on your own network. You still need permission to do this on your own network. There are system administrators who have been fired and jailed and fined money because they were doing security testing on their company network without permission. It might have been their job to do some security, but it was not their job to do penetration testing. And they did not have permission from the senior management of their organization. Find out who you need permission from to do this on your own network and make sure you have it in writing. You know, CYA, cover your butt. Save the email, get it written down, and make sure it's very explicit on what they are giving you permission to do. Okay, so back to the virtual machines. Let me just go back here to the very beginning. For anyone who hasn't seen it already, we're going to be using virtual machines on the APNIC Academy. The website address is just academy.apnic.net. The APNIC Academy is open and free for everybody to access. Everybody worldwide, 24 hours a day, 365 days a year. It is not limited to the people in this room. So if you see things on here that you think may be useful for your colleagues, for your students, for your friends to be learning, point them to it. It's free, like completely free. You do need to create an account, but it's very simple. It's your name, email address, and a password. Done. That's your account created. When you go into the academy.apnic.net, you're looking for virtual labs. And from the virtual labs, we're going to be launching the vulnerability scanning and penetration testing lab. Now, where am I at for timing? Now, is this only going to 1:30? I need to make sure I don't go over time because you guys have other sessions to go to. Oh, no, half an hour more. Okay, cool. 3 o'clock. Don't let me go over. There's coffee, there's tea, there's sweets and biscuits out there, and we cannot miss out on that because it'll run late for the next session. Okay, so half an hour. So you can follow along on this now. We can go through, we can do the presentation, show things later, however you wish to do it. So when you log in, there's going to be 3 virtual machines. 2 of them are servers. We do not log into those servers. Like, you'll see the username and password. Don't log in. The whole purpose is that these servers are sort of outside that you're going to be doing penetration testing and scanning against. The one that we're going to be using is called Kali Linux. Kali Linux is just a Linux distribution that has a lot of security tools pre-installed. You don't have to use Kali out in the real world. There's other distributions. You can also just use regular Linux. You can use Red Hat or Ubuntu or Debian, and you can individually install the security tools that you want. There's no magic to Kali Linux other than it's already pre-installed. The username for that virtual machine is root, and the password is tour, which is just root backwards. You can open up a command terminal, run ifconfig, and you should see the IP address of 101. Now, the 2 other machines are called Metasploit or Metasploitable 2 and 3. They have the IP address of 102 and 103, respectively. Now, you may have heard the tool Metasploit before. It's an attacking framework that lets you do penetration testing. Criminals, of course, can use it as well. You know, it's a hammer. You can use hammer for good things. You can use hammers for breaking windows as well. And the company that makes Metasploit, they created these virtual machines. You can download these virtual machines. They purposefully have lots of vulnerabilities on them, like hundreds of vulnerabilities, so that you can learn vulnerability scanning and penetration testing tools. You know, if these didn't have vulnerabilities, then you'd be hitting a brick wall so many times. You don't know how to actually break in. So hundreds of vulnerabilities, and the slides that I walk through here is only a few little vulnerabilities. So I'm only showing you a few. To learn the whole thing, of course, this could be like a 2-week-long course in penetration testing, which we're not going to go through. Yeah, if config, yeah. So if you're used to Windows, ifconfig is like ipconfig, but on Linux it's ifconfig, interface configuration. So the first tool to look at is called Nmap. Nmap has been around, oh geez, I used it when I was back in Canada back in the late 90s. So Nmap has been around for like over 25 years. It stands for Network Mapper. It started off as a very simple port scanning tool and has grown and grown and is like, it's a simple tool, but it also can be extended and can be quite complex in what you do. This is used by security professionals. This is used by criminals. This is used by network engineers that have nothing to do with security and just want to map out their networks as well. So a lot of different purposes for this. Nmap is actually so common of a tool within security that whenever a movie wants to be realistic, they actually will use Nmap. They'll have the movie character, you know, hacking in, and they'll run Nmap and they'll see it on the screen. The creators of Nmap love it whenever their tool is in movies, so they actually take screenshots from the movie. So if you want to see, you know, from the Matrix Reloaded, when Trinity is using Nmap or whatever, go here and they have screenshots from the movies of the tool being used. Also, just for your reference, down here for the attack lifecycle, whenever we go to a different stage, you'll see a red box at different stages. So we're going to be doing initial reconnaissance and information gathering for a lot of these tools. So Nmap, this is the way that I lay it through. So I introduce a tool. I then give you the very easy starting point of how to use the tool, understand the output, and then we make it a little bit harder. We go a little bit deeper into the use of that tool. And then at some point, we then move on to a different tool. There is so many different ways of using Nmap. I'm only going to be showing you a few of them along the way just to get you started. And hopefully, if it's something that interests you, you can then bring up the manual pages. You can bring up all the documentation online, and you can figure out all of the hundreds of different options to configure the way that you use the tool. But I start off with just some introductories here. So the way that you use the tool, Nmap space -SS. The first S is lowercase, the second S is capital. The first S is saying we are doing scanning. So there's different things you can use Nmap for. We're doing port scanning here. The second S tells you what type of scan that we're doing. And what we're doing is a SYN scan. So if you remember the TCP three-way handshake, you send a SYN packet, you get back a SYN ACK. If the port is open, you get the SYN ACK, and then it finishes with a final ACK. If the port is closed, you send a SYN, and you get back a reset. And that's because it's saying, reset the connection, this port is not open, we're not talking on this port number at all. Now, the SYN scan that we do here, we send a SYN. If the port is open, we get a SYN ACK back, and then it stops. Nmap does not finish the three-way handshake. Because the three-way handshake is not finished, the server won't create a log file for it. So if we're talking a web server, if we're talking an email SMTP server, it will not create a log entry because it's as if the connection got interrupted in the middle and it doesn't establish the three-way handshake. So this can be a little bit stealthy. There are network devices, though, that will notice these sort of half-open connections and go, ah, this looks like a port scan. So from the server side, it's a bit stealthy, but if you have the right network intrusion detection system and you have the right thing being tuned, a network IDS will actually spot something like this. So the next scan that we're doing here goes a little bit further. Now, remember, the SYN scan doesn't finish the three-way handshake. So because of that, it doesn't connect to the server. And if you don't connect to the server fully, you can't talk to the server. If you can't talk to the server, you can't ask it, what version are you running? So this is the next step up in the scanning. So here we're using network netmap-sv, the lowercase s, we're doing a scan. The capital V says we're doing a version-based scan. Now, for a version scan, it does finish the three-way handshake. It does talk to the service, and it says, give me your banner message. So many network services, when you first connect to them, will actually say, hi, I'm running SendMail version 123. Welcome to this server. Or, hi, I'm a web server. I'm running Apache version 2.3.4. So they expose this information automatically. So this version scan connects to a port and waits for that banner message to see what version of the software is running. Now we're adding on something else here. This is a capital O, so not a zero, not a lowercase o, but a capital O, and that stands for operating system detection. This is an interesting bit of technology. This could be a whole, deep dive into the research behind how this is done. But whenever a kernel, whenever an operating system implements TCP/IP, they implement the standards, the RFC, right? But the RFCs have some wiggle room. An RFC is not 100% it must be this. So when it's doing a scan, when it's connecting to the operating system and to the network, it's looking at things like, hey, what sequence numbers are you using? What MTU are you using? What are some of these different flags that are being used for different purposes? And they can actually fingerprint the TCP/IP stack and determine what operating system is being used behind it. Now, it's not perfect, but it can definitely tell you a Windows machine from a Linux machine from a Cisco iOS-based router. It can absolutely tell you that, and a version range as well. So this is an interesting one. This scan here will give you version information. This scan will say, this is a DNS server using this software. This is a web server using this software. This is a mail server running this software. Now, this is all being TCP-based scanning up here. Also, by default, because we're not telling it what ports to scan, it's scanning the 1,000 most common ports. So port 80, port 443, port 445, things like that. You can define which ports to scan using -p. And if you want to change it to be scanning UDP, you do -S capital U to tell it to do a UDP scan. So we can take this port scanning and put that up to there for TCP scanning if we wish, if we only want to scan a few ports or specific port numbers. UDP scanning is going to be a lot slower though. So when you're doing this, that's why I recommend that shortening of ports for the learning here. That's because for UDP scanning, there's no three-way handshake. So I may send a UDP packet to you saying, hi, I want to talk to you. And then if you're actually listening on, say, UDP 53 for a DNS server, you reply. But I may then connect to another port and say, hey, I want to talk to you. But if the port is closed, I won't get a message back. But I don't know if it's maybe a slow connection or if the message hasn't come back yet, or maybe it's just closed. So UDP scanning sends out the UDP requests and then waits to see if there's an answer coming back. That can be very slow. Mind you, if you're running it overnight or you're running in parallel, you can run this wide open and see whatever UDP ports are open. But the exciting stuff is on TCP. Nothing exciting runs on UDP. I'm joking. So the next bit to look at is using different functionality for Nmap. One of them is that you can output, not just to your screen, but you can output to a file. Now, there's a few different versions or a few different formats of this output, but this example here, we're looking at the more complicated one. -lowercase o for output, and the capital X is saying that we're using the output format of XML. When you output in XML format, it's not meant to be human readable. Like it's plain text, it's not binary. But if you did a less on that file, it's just going to be XML, looking like HTML sort of thing. It does give you a lot more information, but it's used for other programs that can interpret XML, not so much for you as a human. So here we're doing an nmap, we're doing a scan of the version scan, we're doing outputting to XML, we're then putting the output file name, and then at the end we add the IP address of what we're scanning. That will then record that information to XML. Now, where the really interesting thing comes in is that nmap has another tool in its package called ndiff. Now, the Unix command called diff will look for differences in a text file. But because it's XML, it's quite long and it's got all the different tags and stuff. So ndiff is the nmap difference tool that understands XML and will actually look for the readable differences within that XML format. Now, this is really useful. If you do an nmap scan of your network and you look for all the ports that are open and you look for the services that are responding and the version numbers as well, and you do that scan and you save it to a file. Now, tomorrow, you come back, you do the exact same scan. You now have the output from the scan yesterday and the output from the scan today. If you do a difference between them, you will spot any changes that have happened to your network over the past 24 hours. Now, it's really neat because by going back and doing, where's my back button? By doing a scan like this and saving it to a file that actually has like a date stamp on it, and then doing an ndiff, you can actually script this up. You know, you don't have to get complicated. Bit of Python. If anybody wants to use Perl or Go or anything like that, you're more than welcome to. Even Bash scripting will work for this. And you can script it up that you can do an ndiff of nmap yesterday's date against nmap today's date and do an automatic scan, an automatic difference check, and then take the output and send it to you by email. Now, every morning when you come into work, you can have an email that tells you what has changed on your network over the past day. Version numbers on network services, machines that were up and are now down, different ports that are open or not open, which means also if you're scanning from outside your firewall, it not only will detect differences in the services, but it will detect differences in your firewall rules, which is really, really powerful. So yeah, and this is all free. Like this is the most free, the simplest tools, easy to run through and go through. So yeah, going through that exercise, really nice and easy. Now, for the people that don't like doing a lot of things on command line, there are other tools. There are graphical tools on Linux that you can use as well. The example here, we're going to be using a tool Sparta. Sparta is basically a combination of many tools together. Nmap is at the core, but it does many other things. You can scan an entire network, collect information, and then review it in a visual graphical interface. One of the examples of the extra things, if Nmap finds a database server, then Sparta will run up a database brute force password guessing tool. And it will attack your database server guessing the passwords to see if you're using any default passwords. If Nmap, as part of Sparta, if it comes across a web server, then it will actually go connect to the web server and take a screenshot. So not only when you're looking through the results, not only do you find port 80 or port 443, but you can view the screenshot to see what web server it was that it's actually connecting to. So really interesting tools. Now, I mentioned that Nmap is very extensible as well. It's extensible through these scripting tools. So it's an entire scripting language. You can write your own scripts for here, or there's plenty that are included by default. So when doing a port scan, so here we're doing an Nmap scan, we're specifying port 445, which is that NetBIOS over TCP port for Windows machines. And here we're telling it to execute a bunch of scripts. Now you can give the scripts by name individually, but you can also use wildcards like the star character. And the names start off with the most generic and then becoming more specific. So here we're running all scripts that start with the name smb-enum. Enum is for enumeration, trying to gather information from it. I could also do smb star, and that would run every single script that's meant for SMB. So interesting things. So this will then interrogate, this will connect to your NetBIOS port on Windows machines and try and gather information. What domain is this joined to? Is it maybe just a workstation? What information is available anonymously? This is just running it against the two different IP addresses at the end there. One of them is a Windows server, and the other is a Linux machine running Samba, old Samba. It's purposely configured very insecure. So the second one, you will get a lot of information from it. You can also run default scripts. The default is not for any specific port number, but if you're doing wide scanning against all top 1000 ports, you can also do the default scripts. It's going to be very noisy. It's going to be doing a lot of connections to the server, but it's a great way of collecting information from servers that you're trying to do scans and connect against. Don't worry about this one too much. Enumeration for Linux, this is just a different tool that does the same thing as the Nmap scripts do, but just showing that there are different tools out there. If there's something that needs to be done on the internet, there's going to be 5 different ways of doing it at least. And then someone's going to look at those 5 and say, I don't like any of those. I'm going to write my own. And now you've got 6 different ways of doing something. So there's always going to be different tools like this. So you don't have to use Nmap to do NetBIOS enumeration. You can also use enum for Linux or any of the other ones that are out there. Okay. This one's a bit interesting for anybody who works on the networking side of things. This is one that you may want to pay attention to. This is where we're going to be scanning for SNMP services. So SNMP, the Simple Network Monitoring Protocol, commonly used for getting statistics information from routers and switches and firewalls on managed networks. It allows you to query, pull down how many packets are going through an interface, how many bits or bytes are going through an interface, and give you those pretty little, network monitoring graphs. Now, SNMP can give away more information. It can be configured in many different ways, usually in read-only state, but it can give away sensitive information. Now, SNMP, depending upon the version that you're using, may only use community strings, which is sort of like a password, but there's no encryption, there's no hashing, and a lot of people use default community strings or the same community string on all machines. So what we're going to be doing is we're going to be using some tools to be able to do scanning and testing for SNMP community strings. Now, this is where we introduce you to the concept of word lists. So this is the path on that virtual machine to get to some default word lists. Now, a word list is, simply put, a list of words. You can have a word list for the entire English dictionary. You can have a word list for the top 1 million passwords that have ever been compromised on the internet. You can have a word list for all of the common and default SNMP community strings. And that's what we're going to be looking at here is the SNMP community strings. Now, you can edit this text file to include your own SNMP community string, your current one, maybe some old ones that used to be used on your network. And this will go through, scan your network for all SNMP listening services, test all the community strings, and tell you which devices are using which community strings. Basically, password brute forcing. Yes. Oh, no, that's ZenMap. This one's different. Yeah, no, I haven't talked about ZenMap. ZenMap is a different Nmap type of scanning tool. So, that ZenMap is a different one. There's many different Nmap replacements out there, and ZenMap is just one of them. But yeah, this is going to be using something different. So this is just introducing you to the word lists. And then on the next slide, this is the tool for SNMP scanning here. So the tool is called 161. Does anybody know why the tool would be called 161? What do you got? It's the SNMP port, absolutely. So SNMP listens on port 161. So the person who wrote this tool decided to just call the tool 161. So here we're running this on the virtual machine that we're looking at. We're actually going to be scanning the local host for the SNMP service. So it's, you could scan an entire network, but you can see we're just scanning local host here. You can see that we're doing -C and we're feeding in the community string file. So that's just the text file from the previous slide. It's just a list of community string passwords. And you run that and it will very quickly brute force and tell you which community string is being used. Now, the community string by default is public. Like literally it's the word public because that's just the most default community string out there. I wrote just a very simple bash shell script here that will actually change the configuration. So it just rotates between two different SNMP configuration files and then reloads the service. If you run this, it changes what the local host is using. And then you can run this command again, and you can see that even though we've changed it from the word public to something a bit more complicated, it's still going to find that community string. Now, the brute forcing here is not guessing every single letter and number combination. It's only using whatever exists in this file. So if you're using a community string that does not exist in this file, it's not going to brute force your password. It's a very simple brute force checker for SNMP community strings. Now, once you have the community string, you need to do a bit of an audit to see what information can be exposed on my SNMP service from that particular network device that you're using it on. SNMP check, just as the name implies, it just does a very small check to tell you that it can connect via SNMP. And SNMP walk will actually walk through the entire OID tree and give you every single piece of information that can be queried on that device for SNMP. So the first tool back here, 161, this can scan across your entire network, looking for all devices that are listening on SNMP port, try and find what community string that it has, and then you would come back and use a tool like this to do an audit on what information can be exposed. Now, if it's exposing sensitive information, you need to be aware of that, and you may need to protect that a little bit more. Maybe a longer community string, rotate your community string, or use SNMP version 3, which actually supports username and password, encryption, and proper authentication for it. But yeah, the SNMP walk will go through and give a whole big list of output. Most output that you'll see from SNMP will just be numbers, statistics information on how many bits, bytes, and packets have been passing through and what the uptime is for interfaces and the device. But it's possible some systems will give away configuration information, interface naming, or possibly even hashed passwords. So this is a way of actually verifying and testing what information is your SNMP service giving away. This example here, when we run this on the local machine, obviously this is just a Linux machine. So the Linux machine doesn't have 50 interfaces and sub-interfaces like your routers would. So the information that you see here is quite simple, but doing this on a real router, firewall, network switch, you'll get obviously more realistic output from that. Make sure I don't go 6 minutes. Okay, cool. OpenVAS is another one. OpenVAS is the next tool to look at, and this is a vulnerability scanner. This vulnerability scanner is a free tool that you can download and use. It's now being run by an organization called Greenbone. Do I have it on here or the next one? Yeah, the web user interface was created by Greenbone. Now Greenbone, the company, is providing a commercial tool for it. OpenVAS is a fork from Nessus. So back before Tenable Networks was started up as a corporate entity, Nessus was a free open source vulnerability scanning tool, and that's where OpenVAS comes from. The OpenVAS tool's not running on the Linux machine by default, so we have to start it up, then connect to the local IP address. You can log in and you can actually go through and view. I think I did 3 or 4 test vulnerability scans, and I was scanning the same set of servers again and again. So you can actually watch the graph change over time. So I did a scan. I then fixed up some services. I patched them. I changed configurations. I did a scan again. I then patched some more. I did a scan again, and then I rebooted the machine. Some vulnerabilities came back. So you can actually watch a realistic graph of how many vulnerabilities are scanned over a period of time for these virtual machines. So yeah, really interesting stuff. OpenVAS is a great free vulnerability scanning tool. You can pay for the commercial version, but you can absolutely download the community version. I think you can download it as like packages that you install on Linux. You can download it as a virtual machine. You can download it as an ISO to do an installation. But yeah, absolutely. If you're not doing vulnerability scanning already, there are free tools that you can get quite a bit of usefulness out of. And even if you outgrow the free tool, if it doesn't go as far as you want, you can always go to the commercial vendors and get like a 30-day trial version of their software. You know, get the trial version, install it, do scanning for 30 days, fix as many vulnerabilities as you can, and then the trial ends and you just uninstall the software and you're good. So yeah, absolutely. Make use of free software that's out there. So yeah, vulnerability scanning, really, really useful stuff. This still falls in the reconnaissance space. You know, we're not hacking into any servers or anything like that, but really, really useful. Nikto is a specific scanning tool for web servers and web applications. So what we have installed on the local machine and the virtual machine here is just a default installation of Apache. One thing that's very interesting with this is that you're going to find some false positives. And this is a really good example of why you need to have security-minded people to understand the output from some of these tools. So some of the information that it tells you is going to be real, and you go, yeah, we need to add this header in to make our web application more secure. But it's also going to give you something and say, you know, oh, there's a path traversal vulnerability. But when you go and you actually manually test the path traversal vulnerability, you realize that instead of giving you the password file, it's giving you an error page. So it's misinterpreting the results and giving you actually a false positive. So this is where you have to understand, knowing how to run the tool is like 1% of the job. The other 99% is how to read the output, how to interpret the output, and understand what is a true positive, what is a false positive, and how to do that verification process, which takes more time and experience and testing of things. So yeah, so Nikto, great for scanning against web applications and servers. Okay, getting on to the good stuff, and I've got 1 minute to blast through this. So we're using the tool Metasploit here. Metasploit is the exploitation database. This is where we're actually going to hack into a machine and do that initial compromise. Really interesting stuff. We're from this point pretending that we're starting from the beginning. So pretending that the rest was just learning and education, now we're putting it to practice. So we're going to do an nmap against the meta number 2 machine. We're going to see what IP address, what ports are open, what versions are there, and we're going to find the FTP server is running VSFTP version 234. Now that on its own is not exciting. If you do a Google search on this, you'll see people talking about it having a massive vulnerability. Aha, we found a service running an old version with a big vulnerability in it. We're then going to run up the Metasploit tool. You can actually do it graphically or from the console. The help command is very useful. Let's see, does my mouse work? No. So the help tool, very useful. Don't think that it's just there because help, but no, help within the Metasploit console is very good. From here, we're just going to do a search for VSFTPD, and we're going to get this back. Here it's talking about version 234, and it's an excellent ranked vulnerability, and it says it's backdoor command execution. Cool. This means that we can actually break in and run commands on the server we're breaking into. This line here sort of looks like a directory structure. It is. We're going to use that line. We're going to use that vulnerability. Info gives us information about it. Options tells us what options to configure it. Our host is the remote host. So we're going to attack a remote host within the virtual machines. But we're attacking the remote host of the Meta 2. But the exploitation is sort of like taking a rock and throwing it to break a window. We're breaking a window to break in, but the really interesting part is, what do you do after you break the window? What do you do after you break into this machine? And what you do is a payload. A payload is a piece of software or external commands that you're going to be running to actually do something on this machine. The payload we're going to be using is an interactive Unix command line. And after you do a very simple set the IP address, set the payload, execute the run command or the exploit command, boom, you've hacked into the server. It's as simple as that. You found a vulnerable version. It exists in Metasploit. You use Metasploit, you configure the IP address, boom. So you've now broken into the server. Also note, you don't have to use the run command. If you want to feel like a real hacker, you can type exploit instead. It's the exact same thing. But for anybody who watched Star Trek, you remember Picard? He'd say, engage. He wouldn't say, let's go. Because that's not like, let's go. That's engage. So exploit, it's like exploit. Once you hack in, you're going to see a black screen. You type commands and you're running commands on that server. If you typed ifconfig, you're going to see the IP address of the machine you just hacked into. If you run whoami, you're going to see what level of permission that you have. So you're going to see that you've got a root shell on the server because the FTP server was running as the root user, which is a bad thing to do, right? Because if someone breaks in, they now have root on your server. The next step for establishing a foothold, I use a very, very simple example here. We add a user, we give the user a password, we add it into the sudoers file to be able to gain root access again, and now we can SSH into the server directly as root. Pretty cool, hey? So that's us establishing a foothold and this escalating privileges. This line gives us that privileged escalation as we go through. Once you've logged back into the server, you can then run nmap from the server that we've just compromised to scan a bit further. So that's the next step of internal reconnaissance as well. Pretty neat, hey? Whoever thought hacking into a machine could be that easy? Now, of course, it's a very old vulnerability. It's easy to exploit. This is a learning environment to make it easy. But the steps that you follow through here, criminals can use against your machines as well. If you're running old versions of software that have vulnerabilities that haven't been fixed, that's the exact same process that a 12-year-old on the other side of the world can do without even knowing who you are, where you are, why you are, and just find a weakness on your machine and exploit it using tools like this. There's then one more example. This one goes through and does the same thing to the Windows virtual machine, doing an nmap scan, searching for the vulnerability on Metasploit, setting the options, and running the command, and boom, you've just hacked into a Windows server. Pretty cool, hey? After you hacked into a Windows server, you can do other fun things, of course. This is also an example that Metasploit can be used for other things, not just the exploitation, but you can use Metasploit to do SSH version scanning if you wish to as well. Metasploit is a huge tool that has a lot of features and options that you can use for. There we go. I've gone 5 minutes over. We have a little bit of time. If anybody wants to ask like 1 or 2 questions. Okay. One quick question.
Thanks, Jamie, for such a detailed presentation session about pen testing and some tools as well. My question is, what if we need comprehensive pen testing of cloud-based infrastructure? Like, could you tell us something?
So probably the best thing to do is look at the vulnerability assessment tools first. So there's vulnerability assessment tools that you can give it a read-only API key or account to your cloud infrastructure. So it can log in and it can do a read-only to check your configuration settings and stuff. The problem with cloud is usually in the cloud configuration. If you're talking containers specifically, it can then scan for versions of software on containers as well. So that's usually where a lot of the misconfigurations and problems are. If you're talking about the actual, like a full virtual machine running in the cloud, then you would just treat that like a regular server. It would have an IP address. You can do a scan over the network, or you can install an agent or give it a login to a Windows or a Linux machine for a vulnerability scan inside. But if you're doing penetration testing, give them that white box information. Tell them the IP addresses that are being used, point them to the right place so that they can do the testing that way. But yeah, that's where you probably need to give a bit more access. Give them what your configuration looks like. You know, if you're using AWS, what are all the individual identity profiles and identity management configuration? That's where a lot of those weaknesses are. The cloud basically takes the same vulnerabilities on a server and adds on a lot more possibilities because of all the cloud configuration on top of it. So yeah, it's going to be an interactive exercise, not just pay money to someone and say, pen test my network. So yeah, the cloud makes it a little bit more. But definitely look for vulnerability scanning tools that can do scanning for cloud configuration as well. Absolutely. You know, if you're running, because remember, from a simple perspective, if you're using the cloud as like virtual machines in the cloud, it just is you're running a server on someone else's hardware. So from that perspective, it's still going to have IP addresses, it's still going to listen on ports, and it's still going to communicate the same way. So yeah, from that simple perspective, virtual machines in the cloud, it's just a server on someone else's network. Yeah. Okay, one question and then we'll break.
Okay, actually, I don't have any question, just a query. From where we can download this material? So if we do some practical, the commands you told us, so from where we can do this, download this?
So from here, all the virtual machines, of course, you can access there. If Kali Linux, you just search Kali Linux, I think it's kali.org, you can download the Kali as a virtual machine for all the tools. And for Metasploitable 2 and 3, just do a Google search for Metasploitable 2. Metasploitable 2 is the Linux machine. You can download a virtual machine package of it. Metasploitable 3 is the Windows one. It's not pre-packaged, but they give you a list of scripts that you can download, and you give it the Windows ISO file, and it will actually build it up. It's using, you know, like packaging and distribution packaging tools and stuff. Oh, the presentation, the actual PowerPoint slides. Sorry. On Sketch, so on the actual, on the schedule, so you know, on it's probably not going to show up on the screen, but on the schedule system, so APAN58.sketch.com, you'll see different you know, little colored boxes like this. If you go in and you find the one for the security workshop, it will give the information. So that's giving currently the description of this session, and it gives my name and it gives my profile. On there should become a link later today, early tomorrow morning. No, I haven't put it on yet. So I have to put it on there myself. So yeah, so you should be able to find it on there. If you don't find it, send me a message either by email or by LinkedIn or something, and I'm happy to share it that way as well. If I can just have my slides back up for a second. But yeah, on the slides that I had, it's got my email address on there as well. Let me. Or actually, no, this one didn't have my email, it just had my name, didn't it? Well, that's not very good of me. There you go. There's my email address. It's really simple, jamie@apnic.net. You don't get any more simple of an email address than that. So yeah, feel free, if you don't find it on Schedule, feel free to reach out, email me. The PowerPoint presentations that are created by APNIC, they're all being released as part of Creative Commons. So you can take them and use them for non-commercial purposes, as long as you give credit to APNIC on where the slides came from. The virtual machines, the APNIC Academy, the recorded webinars, those are all freely accessible for anybody, as long as you just create an APNIC account to access the Academy. So yeah, please make use of the free resources. But I'm not going to hold you back. We have 19 minutes for the afternoon coffee snacks break. I'm going to be out there getting some caffeine and sugar myself. Come talk to me, ask some questions. Also, I was talking to one of the organizers. We might be adding a third security workshop session, maybe on Wednesday or Thursday. Before lunch, remember we voted on topics and we only had time for that first one. So I'm trying to get a third session added on Wednesday or Thursday. Keep an eye on the program. If it does get changed, the organizers will hopefully send an email to everybody saying, hey, a new session has been added. So we're going to try and have it so it doesn't compete against other sessions so that you can come back. And we'll talk through, I think it was security basics and definitions and threats and countermeasures to confidentiality, integrity, and availability. Those two go really well together. Should be able to cover that in the 1.5 hour session. But a really good solid introduction to security and terminology, like defining threat, vulnerability, risk, how they all fit together, how to calculate risk scores as well. So hopefully that will run on Wednesday or Thursday, and hopefully I'll see you then. Thank you very much for your time, everyone. Go enjoy some of the snacks and treats and enjoy the rest of the week at the APAN meetings. Thanks, everyone.